Toyota's commitment to safety is certainly excellent. I think their cars tend to have excellent safety ratings in terms of passive safety, and obviously what they've established with the CSRC and the collaborations with groups like ourselves and the others, shows an impressive commitment to safety from a wide variety of perspectives. So we're obviously very excited to be a partner with them.
Next topic is seniors, brain training, Drs. Kazu Eby and John Anton. John is from Virginia Tech Transportation Institute. Kazu is one of our researchers at Toyota Technical Center and Collaborative Safety Research Center in Ann Arbor.
So good afternoon, everybody. I'm Kazutoshi Ebe, an executive engineer of CSRC. We are studying the effectiveness of brain training for senior drivers in limiting the risk of reduced field of view associated with age. And we developed in-vehicle training system. And we have the actual car behind you, so visit us after presentation. Our project goal is to train senior driver using desktop or this in-vehicle training tool to expand useful field of view, speed of processing, and also to identify and to verify driving safety benefits. I will now turn it over to Dr. John Anton and he explain more.
Thank you. It's a pleasure to be here today. So we know that as we age, we tend to accumulate functional deficits in the cognitive, visual, and other aspects of our faculties. But research has shown that cognitive training can help to improve or reverse some of these different types of trends. So on the one hand, we have evidence from neuroscience that suggests that neuroplasticity is illustrates the capability of our brains to actually change and learn throughout the course of our lifespan. And we also have research, on the other hand, that suggests the long-term safety-related benefits from these sorts of cognitive training programs. So where do we fit in? We fit in, I think, somewhere in the middle, where we're trying to look at actual driver performance and behavior metrics to say, if older drivers are learning and benefiting from these types of training, what are the particular mechanisms whereby we're seeing these changes in behavior that would lead us to believe that we're going to actually see these notable increases in safety. So if you look at the image on the right, you see a useful field of view represented by the yellow circle. And useful field of view is described as the amount of information or the spatial area that within which one can readily gain information from a single glance. So that useful field of view on the right represents the useful field of view for a younger person. If we look to the left, we see the useful field of view for an older person. It looks about the same, but it's actually about 30% smaller in area. And so what do we see? If we look back to the right, the oncoming vehicle may be, in this purely illustrative example, may be captured by the younger person's single glance. And the person may see it, detect the vehicle, and have time to respond to it. If we look back to the left, the older driver, the oncoming vehicle may not be in his or her useful field of view, may not be detected as rapidly, and the older driver may have less time to react to that particular situation. And what we're looking to evaluate is whether or not the brain training can enhance the older driver's useful field of view and speed of processing. So what's an overview to our project? We're going to bring in seniors, 70 years of age and older, give them all a similar pre-test with a variety of metrics, and I'm going to illustrate what these metrics are in a minute. And then they're going to be divided into groups that will each receive different forms of training. One form is a well-known desktop training. The other form, as Dr. Abe already mentioned, is an in-vehicle-based system developed by Toyota engineers. And another group will serve as a control group. Then immediately after training, we're going to give a retest to see if there are any effects. And then we plan to do a series of retests over the course of a year to look at any lingering or long-term effects of these types of training. So what are the metrics? Well, what I hope to illustrate with this next video, it should take about 2.5 minutes, is a variety of the protocols that we're conducting for this study, and it will illustrate a variety of the metrics.
This video will provide a brief overview of VTTI's Older Driver Training Project. When participants first arrive at VTTI, they will complete a series of indoor assessments. Included in these is the Useful Field of View test, which measures participants' sensitivity to peripheral stimuli and their ability to divide visual attention. Participants will also complete standard vision tests. We will also measure neck and torso flexibility using a head-mounted laser. The location of the dot allows us to see how far participants can turn. This is our test vehicle, a 2012 Toyota Camry. On the hood we have mounted red LED lights used for Toyota's training program. These lights are adjustable and removable. Here our experimenter is aligning the hood testing lights with the reflected training lights mounted on the dashboard. The participant inside the car directs the experimenter how to adjust the red testing LED until it lines up with the green training LED. Training and testing will take place on the Virginia Smart Road, which is a closed road course approximately 2 miles long. Before beginning training and testing, participants will drive a lap of the road to become familiar with it. During the training phase, participants will be asked to drive while the green dashboard-mounted lights illuminate, reflecting off the windshield. Participants will not be asked to respond to these lights. If you look closely in the video, you can see the lights blinking off the windshield. In the testing phase, participants will be asked to click a finger-mounted switch whenever they see a red hood-mounted light illuminate. This finger switch allows us to have an accurate way to measure detection performance. Another testing metric we are using is a 3-way peripheral detection task mounted on a headband. Each stalk has a red LED light mounted on its end, and participants are again instructed to respond whenever a light illuminates by clicking the finger switch. Finally, to try to capture real-world hazard detection performance, participants will be asked to call out roadside targets that indicate the possibility of children playing nearby.
Ball. Stroller.
Thank you. So I would just like to again mention that we have the actual test vehicle here in the back of the room, and we also have a competitive game, so you'll be able to test yourselves against one another, and we look forward to meeting and speaking with each of you. So we're starting here in the trunk where we see essentially the brains of the operation. So this is a proprietary hardware and software system developed at VTTI, and all the data collected, which I'm going to talk about momentarily, is stored on an onboard solid-state drive. So some of the types of data we're collecting are accelerometers in 3 dimensions, digital GPS, and a variety of camera views of the driver participant as well as the roadway surrounding him or her, all synced in time so that we can review all the data together back at the lab later on.